Hello everyone, and welcome to section 2. Today we're going to be talking about a strategy to do a very specific type of problem, but this strategy is amazing in that it's useful in not just these types of problems, but across a wide range and massive variety of different problems. So I'm going to be doing some example problems at a later date, but today I purely want to focus on this distance, rate, and time chart, or rule of thumb chart. Many will know this as a triangle, but I was taught this as a circle, and I believe that that is the most efficient way of doing things. So, what is the rule of thumb chart? It's designed to kind of look like your thumb. So, we have this circle here, with a line going across and a line going down. So in the top bracket, we're going to have distance. D is short for distance. In the bottom left, we have speed or rate. These are S or R. And in the bottom right, we have time. This is very simple and looks surprisingly simple, right? But in fact, it has a massive variety of uses. So, when we're talking about distance, rate, and time problems, you could just memorize the facts that speed times time is equal to distance, distance divided by time equals speed, and distance divided by speed is equal to time. That's all well and good. But what happens when you have an insanely complex problem dealing with distance, rate, and time? I want to find a way to solve these problems by thinking through our pen, pencil, or marker. And drawing this circle helps a ton. So let's say I have a journey and I travel 60 miles an hour and I go for 4 hours. Then I can fill in these numbers: 60 miles per hour and 4 hours. And so the distance, I cover up the distance and I multiply speed and time and I get 240 miles. If I didn't know what the speed was, I cover up the speed. We have distance divided by time. That's why time is at the bottom. 240 divided by 4 is 60. Likewise, if I didn't know what the time was, I cover up the time, and we have 240 divided by 60 gives us 4 hours. Now, a more advanced version of this would actually be, let's say I have multiple journeys. I go one way, and then I come back the other way. Or I go one way, and then I keep going the same way. That doesn't matter. What I do instead is I draw a line sort of like this. We have the first journey here. So this is journey 1. We have the second journey here, journey 2. And we have the all-around trip. I'll just call it A. And we have a distance, so speed, time, distance, speed, time, distance, speed, and time. And when we look at the problem, we plug in the values that were given, and we solve for the ones that we still need to know. This is why organizational tools are so efficient. By writing this stuff down, we can easily see, oh, if I have distance here and I have speed here, I can easily find the time. And if I know the time here, then I can add the 2 times and I have the total time. One thing to watch out for is speed. Speed in this case is the total distance divided by total time. And it's always the total distance divided by total time. Remember that. The average speed is the total distance divided by the total time. If you have, say, if I have a speed of 36 miles per hour here and 60 miles per hour here, I am unable to say that the average speed is 36 plus 60 or 96 divided by 2 is 48. That's not necessarily true, and it's only true if the times are the same. but most likely the times are not the same, and so don't do that. Speed, average speed, is the total distance divided by total time. This organizational tool can be used for how many different journeys you have, as long as they're in the same problem. And as long as you have some distance points, some speed points, and some time points, you can plug them in and you're set to go.